Convergence tests for positive series. The first test is integral test. Theorem. Let's suppose that the function f is positive and continuous and decreasing on an interval from 1 to infinity or 2 to infinity. It's not important the beginning. Then, part 1, if the integral from 1 to infinity of fx dx is less than infinity or converges, then sigma fn will be also the same, converges. And if the integral diverges, then the series diverges. Let's explain the part 1 only. Let's prove it. So if I suppose the function fx in red here, so this is in red my function y equal fx. So if I take the area here, if I suppose that here I have 1, 2, 3, so here at the point B, I have f3 in black here, and at f2 is given here in green. Okay. The function is decreasing, positive, and continuous. So in green here, the area of the rectangle is f2 because this length here from here to here is f2, and this length from here to here is 1. So the area of the green rectangle is f2. Now what is the area here in green? Here in green, it's integral from 1 to 2 fx dx. So it's bigger than f2. And also in black here, the area, it's the integral from 2 to 3 fx dx. It's bigger than f3, the area in black. So we can write that if I take the integral from 1 to 2 plus from 2 to 3, so it's the integral from 1 to 3 fx dx. It's the addition of integral from 1 to 2 plus 2 to 3. It's bigger than f2 plus f3. So in general, we can write that integral from 1 to infinity fx dx is bigger than sigma from 2 to infinity fn. So now on the left here, this integral, if the answer of this integral is a number less than infinity, so the answer of this sigma will be also a number. So this proves the first part of this theorem. Let's take some examples. Exercise. We can consider this exercise as theorem and we can use it in the next tests. So show that all the series 1 over n power 2, 1 over n power 3, 1 over n power 4 converges. So the numbers here 2, 3, 4 must be bigger than 1. So in general, sigma 1 over n power b converges if the number b here bigger than, strictly bigger than 1. So it's not 1, it's not equal to 1. For example, here n root n would be written as n times n power a half. So it's n power 3 over 2, 3 over 2, 1.5. So it's bigger than 1. The part 2 in this exercise, all the series 1 over n, sigma 1 over root n, 1 over third root of n, etc. diverges. And in general, if the power here, instead here I have 1 as power, here a half, 1 over 3, 1 over 4, if this number b is 1 or less than 1, So this series diverges by integral test. So let's prove this. So let's calculate the integral of dx over x power b. So let's suppose my function now f(x) is 1 over x power b. So this function positive, continuous on the interval 1 infinity, and it's also decreasing. F is decreasing. You can take the derivative of f and find it negative. Decrease. Why? It's decreasing because f derivative x it's negative. You can write x power minus b, so minus b over x power b plus 1. So it's negative. Okay. So now let's calculate this integral from 1 to infinity. So here it's the integral from 1 to infinity of x power minus b dx. So integral of x power n, x power n plus 1 over n plus 1. So it's x power minus b plus 1 over minus b plus 1 between 1 and infinity. So we can write this as 1 over x power b minus 1 times 1 minus b between 1 and infinity. So if the number b minus 1 positive, so f b minus 1 positive, so 1 over x power b minus 1 when x goes to infinity will be 0. So only in this case, so the answer here will be, let's write in red, will be 0 minus, if I put 1, it will be 1 over 1 minus b. 1 over 1 minus b. This is f b minus 1 bigger than 0 or b bigger than 1. So in this case, only the integral converges. So f b bigger than 1. So this integral from 1 to infinity dx over x power b will be converges less than infinity, but this integral is bigger than sigma 1 over n power b from 1 to infinity. So this sigma 1 over n power b converges from 1 to infinity. And if b less or equal 1, so diverges. And this is exactly what is in this exercise. So if b greater than 1 converges, it's not diverges. Example or exercise. Let's see this series. Test the following series using integral test. So here 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So this is sigma 1 over n from 1 to infinity. The beginning is not important. If we begin with 1 over 2, for example, or 1 over 3, it's the beginning. So it will not change anything. Okay. So here we remark that this is sigma 1 over n power b and b equal 1. And what was the rule? If b greater than 1, so converges. So if b less or equal 1, so this series 1 over n power b from number to infinity diverges. So here in my case, it's diverge. So the final answer of my sigma equal infinity. In this exercise, 1 plus 1 over 2 power b, 1 plus 1 over 3 power b, plus 1 over 4 power b. So it's sigma 1 over n power b. Okay, from 0 to infinity, from 1 to infinity. Okay, so the number here p equal, so this is nearly 3.14, so it's greater than 1, so converges using integral test. Okay, the last exercise here, let's suppose that the function fx is 1 over x times ln x power b. So this function, because the domain of my function is positive, so here, this function, what is the domain of the function? The domain is, domain of the function f is equal from 0 to plus infinity without 0. So because of this, this function is always positive. So it's greater than 0. And f is continuous function because it's composition of continuous functions. And f is decreasing. You can verify by taking the derivative, calculate the derivative, and verify that the derivative must be negative. Okay. Now, let's take the integral. If using our test by integral test, f the integral of dx over x ln x power b from 1 to infinity, from 2 to infinity, because, okay, because the beginning here at 2. Okay, so my domain, I can take it from 2 to infinity, it's not a problem, or from, okay, so from 2 to infinity, it must be, if this integral is less than infinity, then sigma 1 over n ln by ln n power by p from 2 to infinity also converges. So now the question about this integral, how to calculate this integral. So let's suppose ln x equal u. So what is du? It's dx over x. So let's call this integral I. So my integral I equal integral. Instead of dx over x, it's du over ln x, it's u power b. Now, when x equal 2, u is ln 2. And when x infinity, u infinity. Now, from the beginning here, we suppose that p be greater than 1. So this is less than infinity because b greater than 1. So because of this, using integral test, our series sigma 1 over n ln n power e from 2 to infinity converges less than infinity.